Measures of central tendency are very important to us as scientists, okay, to know exactly what is happening in a particular process, okay? And some of the key measures of central tendencies that are used practically are the mean, the median, the mode, and the quartiles, okay? For us as scientists, we use the quartiles a number of times, and we use them in various fields, even in manufacturing processes, okay, for the estimation of quality control limits, and in so many other areas, okay, for analysis. Very good. So we want to begin with this topic. Um, he says, at the end of this topic, we should be able to explain the concept of the measure of central tendency in the description of data distribution, obtain the mean, median, mode, quantiles, then state empirical relationship between mean, median, and mode. Okay, then we also calculate the interquartile range, estimate the mean and quartile from what? The CDF, or the cumulative distributions. Good. So basically, when we talk about a measure of central tendency, then we are talking about measures or statistics which describe what is happening in the center of the data. Okay, we are talking about statistics which describe what happens in the center of what? A distribution, okay, or what you call as data, okay? So for a very simple example, if I want to describe maybe the performance of my former class in the course, I could easily say that, oh, a lot of people scored 80 over 100. When I say a lot of people scored 80 over 100, it gives the impression, it tells anyone, the listener, that people really performed well, okay? Now, that measure or that statistics, a lot of people, is what we refer to as the mode of the data. The highest occurring what? Observation is the mode of the data. I could have also said that averagely you did well. Averagely people scored around 60 over 100. 60 over 100 we know is above 50%, which is the expected what? Center value. So if you say averagely somebody scored, the class scored 60 over 100, then it also gives an impression the class did well, okay? So from these two examples, we can clearly see that measures of central tendency help us to describe how a distribution looks like or what is happening in the distribution. Okay, and as part of our objectives for today, we're going to look at how to calculate the mean, the median, the mode, and the quartiles for ungrouped data and for group data. Now, we know from previous class what ungrouped data is and what group data is, okay? For ungrouped data, you have the data like 9, 10, then I'll give you 11, okay, 20, and I ask you to group them. So you have a number of observations. But for group data, they're already in the class limits. You have the class limits, okay, with the frequencies. So I give you maybe 1 to 11. Then I have 12, okay, 12 to, that will be 10. So that's 22. Okay, then we have, are you getting it? So 23 to 33, okay? Good, then I have the frequency. So this is grouped data, whilst the other data there is ungrouped. So we'll be doing calculation for ungrouped. Then when we are done, we'll also do the calculation for grouped data. Good. With that understanding, okay, let me clear my screen first. Okay. So the mean, yeah, a few characteristics. So when we talk about the mean, the symbol for the mean is what? It's mu. Okay, it's mu. Yeah, the symbol for the mean is mu. Okay. Then is what we mean by mu is mean is also the average or the expected value. The average or the expected value. Then the median divides the data. When we say median, median just means middle number. Okay, middle number. So if you have data, then the median is the middle number. So it will split the data into two equal halves, where you have 50% on the left and then 50% on the right. Okay, and the mode is the highest occurring what frequency, or the observation with the largest frequency. Okay, good. Yeah. So let's move down a bit. We'll come back to all of that. That's why I'm skipping them. Okay, so let's take a practical example. For the mean, to calculate the mean, it is the summation of all observation of the data over the number of observations. Okay, yeah, so we say that mu is what? Is summation xi, okay, from I equals to 1 to n over n. So that gives us the mean of the distribution. Good. Now there is an example down here where to find the mean of the data. We have to find the mean of the data. To obtain the mean, like we said, you have to sum everything up. So we have mean is equals to what? Is equals to 3 plus 6 plus 7 plus 2 plus 4 plus 5 plus 8 over 7. Okay, good. So once you add everything here, this gives us 9, plus this will give us 16, plus 2 will give us 18, plus 4 gives us 22, plus 5 gives us 27, 27, and then plus 8 gives us what? 35. Okay, so 35 over 7 will give us what? Will give us 5. Okay, so that gives us the mean. So what this is telling us is the central value or the central data of this distribution. The average of this distribution is what? Is 5. The average value is what? Is 5. Okay, now let's proceed. We have a second example here. You follow the same principle. So if you want the mean, you sum everything up, okay, and divide by the number of observation. Here we have 20. There are 20 selected screws. So when you find the mean, you get 0.88 grams as the average what? As the average weight of the screw. Okay. Now let's proceed. So that is for the mean of the data. Okay. Now let's look at this question here, or this example. He says here is a set of annual incomes for 4 employees of a company. Okay, we have the data. He says obtain the mean of the annual income, which has been estimated here, okay, to be 11,125 RM. Okay. Then we are told to give your comment on the value of the income in relation to the entire data set. Okay, good. Now, when we look at the value, the mean we just calculated, 11,125. Okay, yeah, but when we look at this observation, we can see that this person is earning far less than 11,125. This guy too is earning far less. This guy too is earning far less. Okay, yeah. So, which means that this guy's annual income, okay, has shifted, okay, the picture in the distribution toward itself. It shifted the picture in the distribution toward itself. Okay, so it makes it look as if a lot of people are earning on the average days, but indeed that is not so. Okay, that is not so. We call this scenario when you have an extremely large value. Okay, we call such a value an outlier in the data, or we call it an outlier. So outliers can affect the value of the mean, or can affect the interpretation of the mean we estimate from what? The data. Okay, such interpretation will not reflect what is happening in the population. Then for the third question, it says, give your comment on the value of the mean obtained. Can the value of the mean play a role as a center of the given data set? Clearly, we can see this is not so. Okay, so when you read carefully, it says the extreme value is shifting the actual position of the mean to the right. Since a majority of income is less than 6,000, the figure 11,125 is not appropriate to be called the center of the first three income. Okay, yeah, it will be better if the fourth employee is removed from this group. Okay, so outliers, when estimating the measure of the central tendency and you find outliers in the data, it will be better you remove those outliers before you proceed. Any question? Any question? Any question? Yeah,
I think we get it.
Charles. Charles.
Yeah, hello?
Yeah, Charles.
Hello, sir.
Yeah,
Yeah, you were saying that when we want to find the mean,
yeah,
we see a bigger figure, we should be able to take it out.
yes.
Uh, um, w- don't you think in certain situation when you take it out, won't it affect the value that we are going to get?
You see, when we talk about measures of central tendency, like we said, we want
Yeah.
to get a picture of the entire distribution. Okay.
Okay.
So, if, for example, let's look at this scenario. You wrote an examination, okay, and a lot of you scored below 50%. And then there were two students in class who scored 100%. Aside them, nobody else scored above 50. Okay.
Okay.
When you find the
Alright.
average, if you call me, sir, we want to know our performance, and I tell you, oh, on the average, the class scored 70. Okay. Yeah, it gives the impression that the class did well, but that is not so. The reason why the class appears to be doing well is because 2 people scored extreme marks. Okay? So if you
Okay.
want to get a true representation for the
Okay.
class, you need to take those 2 people out because they are exceptional. You need to
Okay.
take them out and then do the calculation based on the values from the remaining class. That will give a true reflection of the
Yes.
performance for the class.
Okay. All right.
Yeah.
All right.
Yeah. Yeah. Any question? Any other question? Okay, let's proceed. So it means that is it Charles? You still have your hand up?
No, I'm done. I think
Okay,
I'm okay.
okay, sure. So it means that the mean has a limitation. Okay, mean can be influenced by what? By outliers. Okay, so you take note of that. Very well. We want to continue. Okay. So the next one is the median. Like I said, the median is the middle. Okay, the middle observation or the middle observation. Yeah, the middle data. Okay, and in estimating the median of the data, there are key steps you need to take into consideration, and they've been outlined here. First, you have to arrange the data in ascending order. Okay, then secondly, you find the median position. Okay, or you can find the median position before arranging the data. And then finally, you identify the median. Okay, very well. Now, this formula applies to both even and odd data. Okay, so there's nothing like when it is even, you do this, when it is odd, you do that. Okay, now, example, it says obtain the median of the following data sets. We have this data, 27 observations. They are all 27. Okay, so like we're saying, the first step is to arrange the data in ascending order. Okay, so let's go and arrange the data